Hey everybody, this is Miss Moran. This is our Limits and Derivatives unit. It is video 13. It is our last video for the unit, and it is going to be covering continuity. Have your continuity note sheet with you, and we'll go ahead and get started. Alright, so we're going to be looking here at three different types of discontinuities. A discontinuity is where we see a function is not continuous, as in there's something that makes it stop and you can't run your finger all the way from the left to the right or the right to the left. So we're going to be talking about a lot about where limits don't exist and really specify why they're not existing there. So there's going to be three different names for these. The first one is called an infinite discontinuity. And your infinite discontinuity is, we're going to be looking for asymptotes. Okay, so when you see something that appears to be a vertical, let's add that in there, vertical asymptotes. Okay, so your picture could be something where we have one going up and one going down, or we have two going up or two going down. So this is where we will have what we call an infinite discontinuity. The second discontinuity is called a point discontinuity. And our point discontinuity will be a missing value, which we've been calling holes. Okay, and when this is going to look like something where we have the line coming in from both directions, but there's a hole, and we may also see it where there's also a hole, except there's another place that's been filled in there as well. That's something. And I want you to write the word removable, and we will talk about what removable means as well when we're together. Okay, and the third type is called a jump. A jump discontinuity is when we have the limit from the left and the right not the same. And so what I mean by that is, like, I have it coming in and it's an open circle here, but then it's a closed circle on that side. So this is a jump where there's two different levels as we approach and we come in, and they never meet from the left and the right. All right, let's take a look at an example. Okay, so you've got this picture, and then we've got 6 questions that are to talk about this picture. We're talking about, is f of x continuous over this closed interval from 0 to 8? Another way to write that interval is a card brackets on both of them, and that says all the way from 0 to 8. And I want to know, is this continuous? So I'm going to start here at x equals 0 and go all the way to x equals 8. And I want to know, do I ever have to lift up my finger in order to cross over as I move through these? And the truth is, it is not continuous. Okay, I can say that it's not continuous because I can see lots of things happening. For example, what type of discontinuity is at x equals 4? At x equals 4, I see a jump. There's one discontinuity. If f of 7 equals 1, okay, so right here, f of 7 equals 1, is f of x continuous at, my gosh, typos, at x equals 7. So I'm looking at x equals 7, and I'm saying, is it continuous? And the answer is no. Okay, and I want to actually write down the reason, and it's that I have a point discontinuity. Is the function continuous from 4 to 7, but this time it's exclusive, meaning I'm only looking at the values between 4 and 7, and I'm not including either endpoint. And it's actually, the answer to this one is yes. I'm going to grab a highlighter here just so you can see why it's yes. And if I'm not including the endpoint on either side, then yes, that is continuous from 4 to 7. As soon as I were to include the endpoint of 7 where there is a hole, then this would not be continuous because you could never actually get to 7. Okay, following the line. All right. Name the type of discontinuity at x equals 2. So I look here at x equals 2 and I say, what type of discontinuity is that? And that is an infinite discontinuity. Now this time I want us to split the interval from 0 to 4. Okay, so split the interval from 0 to 4 into two different intervals in which f of x is continuous over both. Okay, so for this one, I'm going to say, well, I'm going to grab a highlighter again. And I'm going to say, well, if I go from 0 to 4, I can be continuous as long as I don't touch 4 or touch 2. And then I can go, well, I'll go from 4 over here as long as I don't touch 4 or 2. So here's how I'm going to write that. So it's actually continuous from 0 included to 2 and from 2 to 4. Now notice I'm using a hard bracket around the 0, which matches my original, and a soft bracket around the 4, which matches the original interview. So we just split that up into 2, and I can actually say that the function's continuous over both of those small intervals, but not over this entire interval. All right, turn your paper over. We'll take a look at the back. Now we're going to use this graph for 3 sets of questions. I'm going to split it up by slides. We're going to do 1 through 6, then we'll do 7 through 12, and then we'll look at 13 and 14. But the same picture. So here f of 1, I just want to know what the value of f of 1 is. F of 1 has a value of 4. The limit as we approach 1, that means coming in from the left and coming in from the right, 2 different fingers, that does not exist. Okay, so if f of x is continuous, or is, my goodness, is f of x continuous at x equals 1? And the answer is no. And we're going to name that as a jump discontinuity. F of 0. F of 0 does not exist. Okay, f of 0 doesn't exist. There's nothing on 0. There's an asymptote right there. Okay, so the limit as we approach f of x, or f of as we approach 0, actually goes to infinity on both sides, which means this is actually positive infinity. Is f of x continuous at x equals 0? The answer is no, because we have an asymptote. So we'd write an infinite discontinuity. So in this picture, we have a place where the function is defined, but the limit is not. And here we have the function is not defined, but the limit is. In either place, I have a no as far as the function being continuous. The discontinuities are different. I have a jump in one place and an infinite discontinuity in another. Next, number 7 is skipping one of my questions. I don't know where 8 went. We'll write it in a second. So f of negative 4, okay, f of negative 4. Over here, negative 4, that looks like a 2 to me. Now the limit as we approach negative 4, okay, so now I'm approaching it, so I'm coming in from this side, and I'm coming in from this side, and I say, oh, that looks like a positive 4 to me. Is f of x continuous at x equals negative 4? And I'm going to say no, because there's a hole, which is a point discontinuity. So I have this hole right here at x equals negative 4. Okay, f of 3. So I go to 3, and I say, well, there's no value there at all. Well, the limit as we approach 3. Oh, that works. The answer is 3. It's got a height of 3. So we've got, again, where the function is not defined at 3, but the limit exists. Is it continuous? The answer is no, because there's a point discontinuity, the hole. All right, last look at this graph here. We're going to list the locations and the types of discontinuities over the interval from 0 to 5. So I'm going to stop here at 5, well, starting at 0 and ending at 5, and we're looking at all the different discontinuities. So I would say at x equals 1, we have a jump. At x equals 2, we have a jump. At x equals 3, we have a point discontinuity. So that is over the entire interval from 0 to 5. Okay, is it continuous over these following intervals? So here I'm looking from negative 3 to negative 2. Negative 3 to negative 2, that's what it says. And the answer is yes. How about negative 3 to negative 2, not including the brackets? Sure, that doesn't seem to change anything this time. How about from 0 to 1, excluding both endpoints? The answer to that one is yes, because I'm not including the asymptote and I'm not including this endpoint. Now what about 0 to 1 including this endpoint? It actually doesn't work. It works on this side, that's okay, but this side is bad because we have the asymptote there. So this one's a no. Okay, how about from 3 to positive infinity with a closed bracket? And the answer is no, because we can't have a closed bracket there. And how about from negative infinity to negative 3? So all the way over here. And the answer on that side is no, because we have this jump. So looking at all of these graphs, we have to draw the conclusion as to whether or not it's continuous and what type of discontinuity might exist. Make sure you try all of those problems, and we'll take a look at this together in class.